Hello dear viewers, you are most welcome and thanks for watching. Tonight we are talking of rationalizing a denominator of surds. And please, if you don't want to miss any step, watch up to the end. And if you are new to this channel, please kindly subscribe, turn on the notification button so that you are notified whenever I upload any video, like and share. Now let's dive in the video. Tonight we are going to talk of rationalization or rationalizing a denominator of surds. And we are saying that in this process, it involves rewriting the surds as an equivalent expression, such that the denominator no longer contains any surd, saying that we make the denominator to completely be a rational number. Remember in the previous lessons about surds, if you haven't watched, the link in the description below, you can tap on it and watch all the videos concerning surds since from the beginning. So we say that surds are irrational numbers, and for us to do the rationalization of the denominator of a surd, we make the denominator to completely be a rational number, as we are going to see. So just watch up to the end. We have part A. We are going to talk of rationalizing a denominator that contains only one term. As you can see below, we have our examples. We have from number 1 to number 8. As usual, I'm going to be taking you through those numbers that are odd. That means we are going to go through number 1, number 3, number 5, and then number 7. The rest are yours to try out. So you get time, try out them, and drop the answers in the comment section. So now let's kickstart on our responses. So straight away, let's begin with number 1. We have to rationalize a surd which is 1 divided by root of 3. So this is the same as, here what we do is we multiply the denominator by itself and again by the numerator. This is what I mean. We are going to get our surd or our expression which is 1 divided by root 3. We multiply the numerator by the denominator and then also we multiply the denominator by itself. So in here we have not changed any meaning of the expression, meaning that in the next step we are going to have 1 multiplied by the square root of 3, which is the same as the square root of 3, divided by root of 3 multiplied by root of 3, the same as having the square root of 3 but squared, whereby we are going to have this root cancelling with this 2, such that we are going to have the root 3 divided by 3, implying that our expression, which is 1 divided by root 3, after rationalizing the denominator, you see the denominator here is now a rational number, which is 3. So these two are equal. Therefore, we have completely rationalized the denominator of this expression, implying that this root of 3 out of 3 is the right answer for this expression number 1. We can move to number 3. We have root of 3 divided by 2 root of 2. As we have done, still we are going to say that this is equal to, you have the square root of 3, we are going to multiply it by the denominator, which is 2 root 2, divided by the denominator, which is 2 root 2, multiplied by itself, which is 2 root 2. Our next step is to simplify. 3 root 3 multiplied by 2 root 2 is the same as having 2 into the square root 3 multiplied by 2. Divided by 2 root 2 multiplied by itself, the same as having 2 root 2, the whole of it squared. As we simplify this, the same as having 2 root 6. If you multiply 3 by 2, we get 6 inside. Divided by 2 squared is 4. Then root 2 squared is same as 2. That means you have 4 multiplied by 2. This is the same as having 2 root 6 divided by 8. And you can see there is a common factor of 2. We can cancel this 2 by, so we can divide 2 by 2, so that we have the root 6 divided by 4. Therefore, our expression, which is root 3 divided by 2 root 2, is the same as having root 6 divided by 4. This becomes our right answer. We can now move to number 5. Number 5, we are having root 7 divided by root 3. You can cross check. It's here. So this is the same as having the root 7 multiplied by the denominator, which is root 3, divided by the root 3 multiplied by root 3 itself. This is the same as having the root 7 multiplied by 3 divided by root 3 but squared. This is the same as having the square root of 7 multiplied by 3 is 21. Divided by root of 3 squared is same as 3. Therefore, our expression, which is square root 7 divided by square root 3 is the same as having the square root of 21 divided by 3. This becomes our answer of the rationalized sides or denominator. Lastly, we can go to number 7 where we have root 2 divided by 3 root 7. So this number 7, we are having root 2 divided by 3 root 7. This is equal to, still the same way, we have the numerator which is root 2. We are going to multiply it by the denominator which is 3 root 7. Divide by the denominator which is 3 root 7. Multiply by itself. So our next step is to simplify. So we have 3 root 2 multiplied by 7 divided by 3 root 7 but squared the whole of it. So this is the same as having 3 root 2 multiplied by 7 is 14 divided by 3 squared is 9. Then root 7 squared is 7. So we have 9 multiplied by 7. Implying that our next step we have 3 root 14 divided by the product of 9 and 7 is 63. We can see that we have rationalized the denominator. Therefore, square root of 2 divided by 3 square root 7 is the same as having 3 root 14 divided by 63. This becomes our answer for that number 7. So you try out the rest. So we've been dealing with rationalizing the denominator of a surd containing only one term. Let's now go to part B and look at rationalizing a denominator that contains two terms. Alright, rationalizing a denominator of surd that contains two terms. And we have our examples here. We have from number 1 to number 8 still. We are going to go through those numbers that are odd. So we are going to go through number 1, number 3, number 5, and lastly 7. The rest are for you to try. I say you drop the answers in the comments section. Let's now dive in. Let's begin with number 1. Number 1, we are having our expression which is 1 divided by 2 plus root 2. So before we embark on this, in here when the denominator is containing two terms or more, there is what we call conjugate. The conjugate of the denominator. For example, if you have the denominator as the square root of A plus the square root of B, the conjugate of this expression is simply to change the addition sign to subtraction sign. Or if it was subtraction sign, we change it to addition sign. Implying that the conjugate of root A plus root B is root A minus root B. Likewise, if I have root A minus root B, the conjugate of this expression is root A plus root B. Implying that in here, for number 1, the conjugate of 2 plus root 2 is gonna be 2 minus root 2. After realizing that the conjugate is this, our next step is now to do the same as for the part A. So we have 1 divided by 2 plus root 2 is equal to our 1 divided by the 2 plus root 2. So now here we are going to multiply our conjugate by the denominator and the numerator, whereby we are going to have our 1 multiplied by our conjugate, which is 2 minus root 2. Then we multiply still the denominator by our conjugate, which is 2 minus root 2. So we are going to simplify this expression to come up with our answer. So this is the same as having 1 multiplied by this. We have 2 minus root 2 divided by, so as we open the brackets, when you look at this expression, we see that this gives us the A plus B, open the brackets close, into A minus B. And this is the same as the difference of two squares. We can treat them like this so that we can save time, or if not, we can go step by step. We open the brackets to multiply each entity by the other, and we shall come up with the same answer. So this time round, we are going to use the difference of two squares. In every denominator, as we multiply the denominator by its conjugate, the expression we get is in terms of the difference of two squares. So we are going to have the 2 squared minus the square root of 2 but squared. So this is the same as having 2 minus the square root of 2 divided by 4 minus the square root of 2 squared is same as having 2. So this is the same as having 2 minus the square root of 2 divided by, so now 4 minus 2 is 2, implying that our expression is same as now having a half into 2 minus root 2, or this very one. We can now conclude and say that therefore 1 divided by 2 plus root 2 is the same as having 2 minus root 2 divided by 2. We can see that our denominator is fully a rational number, which is 2. So this becomes our answer for that number 1. Let's go to number 3. So from here, number 3, the conjugate of the denominator, which is root 5 minus root 2, is the same as root 5 plus root 2, implying that we are going to have our root 2 plus root 3 divided by root 5 minus root 2 being equal to the root 2 plus root 3 multiplied by our conjugate, which is root 5 plus root 2 divided by our denominator, which is root 5 minus root 2 multiplied by the conjugate, which is root 5 minus plus root 2. So in here, I'm going to take you through the other methods of multiplying each entity. So this is the same as having, we are going to open the brackets. We have root 2 multiplied by root 5 plus root 2 plus the root 3 multiplied by root 5 plus root 2 divided by root 5 into root 5 plus root 2 minus root 2 multiplied by root 5 plus root 2. As you simplify these expressions, you can see that root 2 multiplied by root 5 is the same as having root 10 plus root 2 multiplied by root 2 is 2 plus root 3 multiplied by root 5 is root 15 plus root 3 multiplied by root 2 the same as root 6 divided by root 5 multiplied by root 5 is 5 plus root 5 multiplied by root 2 same as root 10 minus root 2 multiplied by root 5 is root 10 minus root 2 multiplied by root 2 is same as 2. This is the same as having root 10 plus 2 plus root 15 plus root 6 divided by, so you can see that this cancels with that. Say that we are having the denominator, which is 5 minus 2. This is the same as having root 10 plus 2 plus root 15 plus root 6 divided by 3. Therefore, this becomes our correct answer for that expression. We can now try number 5. So conjugate of 2 root 3 minus root 2 is 2 root 3 plus root 2, implying that our expression, which is 3 root 2 plus root 3 divided by 2 root 3 minus root 2 is the same as having 3 root 2 plus root 3 multiplied by our conjugate, which is 2 root 3 plus root 2, the whole of it divided by our denominator, which is 2 root 3 minus root 2 multiplied by its conjugate, which is 2 root 3 plus root 2. Our next step is to simplify. So we are going to have the 3 root 2 multiplied by 2 root 3 plus root 2, then plus root 3 multiplied by the whole of this, which is 2 root 3 plus root 2 divided by, we said the denominator here is now a difference of two squares, so we have 2 root 3, the whole of it squared, minus root 2 but squared. So as we simplify the denominator here, we are having 6 root 6 plus 3 multiplied by 2 plus 2 multiplied by 3 plus root 6 divided by 4 multiplied by 3 minus 2. This is the same as, can see that there is a like sides, or there are two like sides. So this plus that, we are getting 7 root 6 plus 6 plus 6 divided by 4 multiplied by 3 is 12 minus 2. So this is the same as having 7 root 6 plus 12 divided by 10, implying that this is the same as 12 plus 7 root 6 divided by 10. So this becomes our correct answer for number 5. For number 5. Then lastly, number 8, number 7. So we have this, and our conjugate is the root 3 minus 2 root 5, implying that our expression is going to be the root 7 minus root 3 divided by the root 3 plus 2 root 5 being equal to our root 7 minus root 3 multiplied by our conjugate, which is root 3 minus 2 root 5 divided by our denominator, which is root 3 plus 2 root 5 multiplied by its conjugate, which is root 3 minus 2 root 5. This is the same as having root 7 multiplied by the whole of this, so that we are having the root 3 minus 2 root 5, we close the brackets, minus the root 3 multiplied by root 3 minus 2 root 5 divided by, so the denominator is a difference of two squares, so we are going to have divided by root 3 squared minus the 2 root 5 by the whole of it squared. This is the same as having the square root of 21 minus 2 root 35 minus 3 plus 2 root 15 divided by 3 minus 4 multiplied by 5. As we simplify this, is the same as having root 21 minus 2 root 35 minus 3 plus 2 root 15 divided by the 3 minus 20, the same as negative 70. So this becomes our answer, whereby the denominator is fully irrational number. Thanks for watching. Try out the remaining numbers, that is, try out number 2, number 4, number 6, and then number 8. Even for this case, try out number 2, number 4, number 6, and number 8. See you again.